Bismillahirrahmanirrahim. Welcome to my YouTube channel Calculus and Mathematics Learning. In the previous video, we started with class 12 mathematics with exercise number 1.1 related with question number 11 and question number 12. Question number 11 and exercise number 1.1 was related with domain and range, and question number 12 was related with composite function. In today's video, we are going to solve last two questions of exercise number 1.1. The question is 13 and question number 14. So let's move toward question number 13. It tells that determine inverse function of each of the following functions. There are four parts in this question number 13. So let's move toward part A. It tells that y is equal to f of x is equal to x plus 5. So we are going to find its inverse. So they tell that y is equal to f of x. So first condition is f of x is equal to y. Now here the power of f is over here is 1. So by shifting to the right hand side, it becomes here we will left with x is equal to, and f will move to the right hand side, it becomes f inverse. Here the power is 1, so it will inverse. So it means that x is equal to f inverse y. Let's suppose this is first condition. After this, they tells that y is equal to x plus 5, or we can also take this y is equal to f of x is equal to x plus 5. Now we can take this equation just like y is equal to x plus 5. Now shift this 5 to the left hand side, it becomes y minus 5 is equal to x. Let's suppose this is second condition. In the first condition, we have x is equal to f inverse y. So put the value of x is equal to f inverse y in this equation. It becomes y minus 5 is equal to x is f inverse y. So put f inverse y over here. So f inverse y. Now in this equation, replace the same y with x, because here we suppose f inverse x is equal to y. Now we can replace this y in the whole equation with x. So replace y with x, it becomes x minus 5 is equal to f inverse x. So this is equal to the inverse function of f of x is equal to y is equal to f x plus 5. This is the inverse f inverse x is equal to x minus 5. Now we are going to find the inverse function of part B of question number 13. Let's suppose use this f inverse x is equal to y. So it becomes f inverse x is equal to y. Now we can also take y is equal to 2x plus 7. So it becomes y is equal to 2x plus 7. Now shift this 7 to the left hand side, it becomes y minus 7 is equal to 2x. Now we are interested in x, so divide both sides with 2. So 2 will cancel out with 2, so we are left with x is equal to y minus 7 divided by 2. Now here we suppose f inverse this is actually f inverse y is equal to x, because we take f inverse y is equal to x, so we can write f inverse y is equal to x. So now put the value of x is equal to f inverse y in this equation. So it becomes f inverse y is equal to y minus 7 divided by 2. Now replace the same y with x, it becomes f inverse x is equal to x minus 7 divided by 2. So this is actually the inverse function of part B of question number 13. Inverse function is a very important topic for the board point of view. Now move toward part C and part D. Part C tells that y is equal to f of x is equal to 2 times of x minus 4 and find the inverse of this function. So move towards solution. Let's suppose f of x is equal to y. This is first condition. F of x is equal to y. Shift f to the right hand side, it becomes x is equal to f inverse y. Now let's suppose this is first equation. Now after this, we can also write y is equal to 2 into x minus 4. Y is equal to 2 into x minus 4. So it becomes y is equal to multiply 2 with x, it becomes 2x. Multiply the same 2 with minus 4, it becomes a minus 8. Now shift minus 8 to the left hand side, it becomes y plus 8 is equal to 2x. We are interested in x, so divide both sides with 2. So it becomes y plus 8 divided by 2 is equal to, here if we divide it with 2, so 2 will cancel out with 2, so we are left with x. So let's suppose this is the second condition. Now put the value of x from this equation in this equation. So it becomes y plus 8 divided by 2 is equal to x is f inverse y. So it becomes f inverse y. Now replace y with x, so it becomes x plus 8 divided by 2 is equal to f inverse x. So this is actually our inverse function. Now move toward part D. It tells that y is equal to f of x is equal to x plus 4 divided by 2. So let's suppose our y is equal to f of x. We can write it x is equal to f inverse y. Now taking the equation y is equal to x plus 4 divided by 2. Here the 2 is in division, so multiply 2 through the both sides. So here 2 will cancel out with 2, so we are left with 2y is equal to x plus 4. Now shift this 4 to the left hand side, it becomes 2y minus 4 is equal to x. So let's suppose this is the second condition and this is the first condition. Now put the value of x is equal to f inverse y in this equation. So it becomes 2y minus 4 is equal to x is f inverse y. So it becomes f inverse y. Now replace the same y in this equation with x for finding the inverse function of the given function. So it becomes 2y minus 4 is equal to, we replace y with x, it becomes 2x minus 4 is equal to f inverse of x. So this is the required inverse function and this is the required question number 13. Now let's move toward question number 14. It tells that draw a graph of each of the following absolute functions. There are 4 parts in this question. Part 1 tells that y is equal to absolute. This straight line, vertical straight line, this is actually called absolute. Can be represented just like this. This is absolute. So y is equal to absolute of x minus 4. This is absolute function and that is that graph this function. So solution. Let I put x, so let I assume the x is equal to 1. So by assuming or putting x is equal to 1 in this equation of this function, it becomes y is equal to absolute of x is, let's suppose 1, so 1 minus 4 gives us minus 3. Remember, absolute is an even function. The even function is definition like that f of minus x will be equal to the f of x. So here this is, let's suppose f of minus x. So it will be equal to the original function because even the absolute function is an even function. So it becomes y is equal to positive 3. So by putting x is equal to 1, we get y is equal to 3. Now let's suppose I assumed x is equal to 2. So by putting x is equal to 2, it becomes 2 minus 4 gives us minus 2. So it becomes y is equal to positive 2. So by putting x is equal to 2, it gives us y is equal to 2. Now assume let's suppose x is equal to 3. So y will be equal to the 3 minus 4 gives us absolute minus 1. So it becomes y is equal to 1. So the order pair form will be x is 3. So by putting 3, it gives us y is equal to 1. Now assume let's suppose x is equal to 4, so it becomes y is equal to absolute of 4 minus 4 gives us 0. So it becomes y is equal to 0. So the order pair form will be x is equal to 4. So by putting x is equal to 4, it gives us y is equal to 0. Now assume y is equal to, let's suppose, minus 1. So by putting y is equal to x is equal to minus 1, it gives us minus 5. Absolute minus 5, it becomes y is equal to pi. So by putting minus 1, it gives us pi. So after this, let's suppose I assumed x is equal to minus 2. So by putting x is equal to minus 2, it gives us absolute of minus 6. So y is equal to 6. So by minus 2, it gives us 6. Let's suppose I put x is equal to 0. So it becomes y is equal to absolute of minus 4. It gives us y is equal to 4. So by putting x is equal to 0, it gives us y is equal to 4. Now I am show the graph of the following function. So let's suppose here the greatest value of x is 1, 2, 3, 4 and here is minus 1, minus 2, 0. So it means that the greatest x value is 4. So on the right hand side I will 1, 2, 3 and 4. And on the x-axis the negative x value is over here is 0, here is minus 2 and here is minus 1. It means the greatest value is, let's suppose I take minus 2. So let's suppose this is minus 1 and let's suppose this is minus 2. Let's suppose this is the origin. So on the y-axis we have 3, 2, 1, 0. It means that the greatest value over here is 3. This is the positive y-axis, 1, 2 and 3. On the negative y-axis we have the greatest value are 5, 6 and 4. So it means that there is no value on this x-axis. On the positive y-axis we will go toward 6. So let's suppose this is 4, this is 5 and this is 6. Now at x is equal to 1 we have y is equal to 3. At x is equal to 1, let's suppose this is x is equal to 1. So we have y is equal to 3. So let's suppose this is 1 and 3. After this, at x is equal to 2, y is 2. So it means that this is x is equal to 2. So y is also 2. So the point will be over here. After this we have x 0, x 4 and y is 0. So this is x 4, and this x-axis we have no y-axis, that's why this here will be the 4 and 0. After this we have -1 and 5, so it means that on the negative x-axis is -1 and the y-axis we have 5, so the point will be over here, -1 and 5. After this we have -2 and 6, so this is -2, let's suppose, and this is -6, because this is 6 and this is -2 and 6, so here we will draw the point. After this we have x is equal to 0, x is 0 and the y is 4, so it means that the point will be over here, 0 and 4. So the graph of the function will be passing from these points, so it will be just like this. This is the graph for the following part A. Now we are going to draw the graph of the part B of question number 14. Y is equal to absolute of -4 and -6x, so that is that draw the graph of this function. Let's suppose I assume the x is equal to 1, so it becomes y is equal to -4 minus x is, let's suppose, 1, so it will give us y is equal to absolute -5 and absolute -5 is equal to 5. So at x is equal to 1 we have y is equal to 5. Now I assume the x is equal to 0, so it becomes y is equal to, by putting x is equal to 0, it gives us absolute -4 and absolute -4 is equal to 4. So at x is equal to 0 we get y is equal to 4. Now I put x is equal to 2, so it becomes -4 and -2, it gives us absolute -6, and it is equal to 6. So it means that at a value of x is equal to 2, it gives us the value y is equal to 6. Now by putting y is equal to, x is equal to 3, it gives us absolute of -4 minus 3 gives us -7, and it gives us 7. So at x is equal to 3, it gives us y is equal to 7. Now after this I am going to put the value of x, let's suppose, is equal to -1, so it becomes y is equal to -4 time of x, let's suppose it is -1, so it becomes y is equal to minus it gives us +1, so -4 plus 1 it gives us -3, and absolute -3 is equal to 3. So at x is equal to -1, it gives us y is equal to 3. Now I assume the x is equal to -2, so the value of y will be, if we put x is equal to -2, it becomes +2. So -4 plus 2 gives us absolute -2, and absolute -2 is equal to 2. So the value of y will be equal to the 2 at x is equal to -2. Now I assume let's suppose I assume x is equal to -3. So it becomes y is equal to -4 time of -4x, let's suppose it is -3. So by putting -3, it gives us -4 plus 3, and -4 plus 3 is equal to -1, absolute -1, and absolute -1 is equal to 1. So at x is equal to -3, we get y is equal to 1. Now I am going to draw the graph for this function. So on the x-axis we have 1, 0, 2, 3, and let's suppose the greatest value on the x-axis is 3. So let's suppose 1, 2, and 3. And on the y-axis we have 5, 4, 6, 7, and 3, 2. It means that on the y-axis we will go towards 7. 1, 2, 3, 4, 5, 6, and let's suppose this is 7. After this, on the x-axis we have negative value towards -2 and -3. So it means that I will move toward -3, -1, -2, and -3. And on the negative y-axis 5, 4, 6, 7, 3, 2, and there is no negative y-axis. So at the value of x is 1, we have y 5. So let's suppose this is x, which is 1, x positive x-axis. This is negative x-axis, this is positive y-axis, that is negative x-axis, y-axis. So when x is equal to 1, the y value is 5, so it means that the point will be over here, 1 and 5. When the x is 0, let's suppose this is origin 0. When the x is 0, so the value of y will be 4, so it means that the point will be over here, 0 and 4. After this, if x is 2, then the y will be 6. So let's suppose this is 2 and the y is equal to 6, so it means the point will be over here, 2 and 6. When x is 3 and y is 7, x is 3 and the value of y is 7, so let's suppose this is 3 and 7. This is 7 and this is 3, so the point will be to the front of 3 and to the front of 7. And here when the x is -1, the value of y is 3, so the point will be over here, -1 and 3. When the value of x is -2, the value of y is also 2. So let's suppose this is -2 and this is 2, so the point will be over here, -2 and 2. When the value of x is -3, the value of y is 1. So let's suppose this is 1 and this is 3. So let's suppose this is minus 3x and y is along 1 is along y axis. So the graph will be passing from this point just like this. If we draw it on a ruler, so this line will be a straight line. I am drawing it with the hands, that's why the line is a curve. This is not a straight. So by drawing it on a ruler, it will be a straight line passing from these points. So this is the graph for the part B. Now let's move toward part C. It tells that y is equal to absolute of 2x plus 5, and let us draw the graph for this function, this absolute function. Let's suppose I assume the x is equal to 0. So it becomes y is equal to 2 multiplied 0 gives us 0 and 0 plus 5 gives us 5. So it means that at x is equal to 0, y is 5. Now I assume the x is equal to 1. So the value of y will be 2 multiplied 1 gives us 2 and 2 plus 5 it gives us 7. So at x is equal to 1 it gives us y is equal to 7. Now I assume that let's suppose x is equal to minus 1. So at x is equal to minus 1 it gives us minus 2 plus 5 it gives us 3. So at x is equal to minus 1 it gives us a value of y is equal to 3. Now after this let's suppose I put x is equal to minus 2. So at x is equal to minus 2 it will give us minus 4 plus 5 and minus 4 plus 5 it gives us 1. So at x is equal to minus 2 it will give us a value of y is equal to 1. So minus 2 multiplied 2 minus 4 plus 5 1, and it will give us a value of y is equal to 1 at x is equal to minus 2. Now let's suppose I draw the graph for this function. So on the x-axis we have 0 1 and let's suppose 0 1 2 3. Let's suppose this is on the positive x-axis, and the negative x-axis we have minus 1 minus 2 minus 3. On the positive y-axis we have 1 2 and 3. So when x is 0, so the value of y will be a value 5. So at x is equal to 0, we get the value of y is equal to 5. So let's suppose this is 0 and 5. When the value of x is 1, the value of y will be 7. Over here the point will be over here 6 and 7. 1 and 7. When the value of x is minus 1, so the value of y is equal to 3. So minus 1 and 3. When the value of x is minus 2, so the value of y is equal to 1. So it means that the graph of this function will be just like this. It will move just like this. So this is the graph for the following function. Now move toward part D. It is the last part of question number 14 and the last question of exercise number 1.1, with which the exercise number 1.1 will be completed. So it tells that y is equal to minus time of absolute function x, and that tells that draw the graph for this function. So let's suppose I assume the x is equal to 0. So by putting x is equal to 0, it will give us y is equal to 0. So it means that our pair form will be x is 0, so y will also 0. Now I put x is equal to 1 in this equation, it becomes a y is equal to minus time of absolute, or let's suppose x is 1. So it will give us y is equal to minus 1. So at x is equal to 1, it gives us y is equal to minus 1. Now put y is equal to, let's suppose x is equal to 2. So it becomes minus time of absolute 2, so it will give us minus 2. So at x is equal to 2, it gives us minus 2. Now I put, let's suppose x is equal to minus 2, x is equal to minus 1, let's suppose. So it becomes y is equal to minus time of absolute x. So let's suppose x is minus 1, minus 1. So it will becomes y is equal to minus, you know that this is absolute function minus 1, so it will becomes a positive one, not minus 1. So it will give us minus time of 1. So at x is equal to minus 1, it gives us y is equal to minus 1. Now let's suppose I put x is equal to minus 2. So it will becomes y is equal to minus time of absolute x. So x is, let's suppose, minus 2. So it becomes y is equal to minus time of minus 2 absolute is equal to 2. So at x is equal to minus 2, the value of y is equal to 2. So this is suppose minus 1, this is minus 2, and let's suppose here we put x positive 1 and here it put x is equal to positive 2. Now we are going to draw the graph for this function. So on the x-axis we have the highest value 0, 1, 2, and here is minus 2. So let's suppose this is 0 and this is 1 and this is 2. This is minus 1, this is minus 2. Let's suppose this is 1, this is 2, and this is 3. This is minus 1, this is minus 2, and this is minus 3. Now at x is equal to 0, we have y is equal to 0. Let's suppose this is on the origin, this point. Now after this, at x is equal to 1, we have the value of y is equal to minus 1. This is negative y axis. So at x is equal to 1, we have negative y axis minus 1. So let's suppose the point is over here, 1, minus 1. At x is equal to 2, we have minus 2y. So let's suppose this is x2 and this is y, which is equal to minus 2. So the point will be over here, 2 and minus 2. After this, we have at x is equal to minus 1, we have y is equal to minus 1. This is x minus 1, this is y minus 1. So the point will be over here, minus 1, and y is also minus 1. At x is equal to minus 2, the y value is minus 2. So let's suppose this is x and this is y. So let's suppose the point will be over here. So minus 2 and minus 2. So the graph of this function will be just like this. So this is the graph for the following part D of question number 13. So with this question, exercise number 1.1 is completed. Thank you for watching, and also subscribe my channel if you like the video, and also hit the bell icon to receive the upcoming notification about exercise number 1.2 and further goes on.